Hello and welcome to the lesson in the nutshell for lesson 1.01 in Math 30-2, which is going to be about asymptotes. So it's our introduction to rational functions. And asymptotes are going to be key pieces in math going forward. So this is related to division by zero. We've known for a while that that's a difficult problem because it's not reversible. For example, 3 times 0 equals 5 times 0 because both sides are 0, but if division by 0 was allowed, we could divide by 0 on both sides, cancel our zeros, and then end up with 3 equals 5, which is nonsense. So division by 0 is not allowed, but the question is, what does that look like on a graph? What happens as you get closer and closer to 0 without touching it? For example, with y equals 1 over x. If we go to our graphing calculator and let y equals 1 over x, we get this graph. And we notice where we're dividing by 0, that's where x equals 0. And that gives us this vertical line. We just put a dashed line so that we know the graph doesn't cover it. And let's do the projector mode display so it's a little easier to see. So our graph approaches the line x equals 0, but never actually touches it. As you have smaller and smaller positive numbers, the reciprocals get larger and larger and larger. So this goes to positive infinity. As we have negative numbers that get closer and closer to 0, again, the magnitude gets closer and closer and closer to infinity when you reciprocate it. This is an asymptote because our graph can get as close to it as we want, but not actually touch it. Now, just because things are not permitted, that doesn't mean there's automatically an asymptote. If we take a look at x squared minus, or the square root of x squared minus 9, this graph will not come close to x equals 0, but it's not an asymptote. To be an asymptote, it's not just a line you can't reach, but it's a line you get very, very close to, as close as you want without touching. So you pick any distance, say 0.001, and you could find a value of x so that this graph is 0.001 units or less away from the vertical line. You can make it 0.0000001, and you will still find an x value that'll get that close to the line. That's what makes it an asymptote. So it is a line you get very, very close to, but don't actually touch. Now, there are two kinds of asymptotes. In today's lesson, we're just looking at monomial denominators. Well, but we will be, and we'll be expanding on those a lot more tomorrow. And then we'll get into binomial denominators. But a vertical asymptote will appear anytime you are dividing by 0 at a single point. So if you have a graph like y equals 1 over x minus 3, well, then you're dividing by 0 at the point x equals 3. So if we have y equals 1 over x minus 3, then the point x equals 3 is our asymptote. In fact, we could say a, and the line x equals a, add the slider, and then we'll see, yes, we don't just have that asymptote here when x equals 3 or 1. We can change what value the a has in that slider, and that asymptote will always go to match. It will be at that exact point every time. So our vertical asymptotes will happen anytime we are dividing by 0. It's called a vertical asymptote because it's a vertical line. But some graphs will also have a horizontal asymptote. For example, in this graph, we also have a horizontal asymptote at y equals 0. Just make that a dashed line too. At no point can we have the value y equal to 0, because then the right-hand side would be equal to the reciprocal of 0, and 0 has no reciprocal. So this is a horizontal asymptote. And if we were to add a value of b to it, then y equals b would be our horizontal asymptote. So let's just change our b a little bit faster so we can tell them apart. And we see we have that horizontal asymptote there, where the whole function equals 0. So these are the key features that we're going to be looking for in our graphs coming up. So in order to be an asymptote, your graph has to get what mathematicians call arbitrarily close to that line. You pick absolutely any value whatsoever, and you could find a point where your graph is at least that close to the line, if not closer. But to be an asymptote, it can never hit that line. Now, in this course, we're only going to deal with horizontal and vertical asymptotes. There are also asymptotes called slant asymptotes that come off at an angle. We will not be dealing with them in this course, but they do exist. So those are the horizontal and vertical asymptotes in a nutshell.